Autonomous robots are able to function without programming or explicit human control, requiring limited oversight to execute specific tasks according to simplified instructions. In order to do this, robots must be equipped with the ability to sense and perceive objects in the environment around them. With OmniRobotics shape-to-motion autonomous robotics technology, 3D perception is used to generate complete images of industrial parts. The 3D reconstruction of these parts is then used to generate robot motions for spray processes. But how is this 3D reconstruction achieved? It all starts with the right type of scanner, specifically infrared depth scanners that, when calibrated, can generate accurate images down to 1 millimeter or less. By firing out thousands of points of infrared light and interpreting their reflection, these scanners can interpret the distance, shape, and position of objects. For industrial parts, however, an industrial-grade solution is needed. That's where sensor fusion comes in. Sensor fusion permits multiple scanners, up to 12 in total, to collaboratively interpret and reconstruct 3D objects in real production environments. From there, these 3D reconstructions are injected into a digital twin and interpreted as planar objects, broken down by AI processes into a series of tiny shapes that then enable a consistent robot motion to be generated. This use of 3D perception and robotic kinematic modeling is so effective that, where sufficient planning time is permitted, robots can achieve a maximally consistent spray process on objects in continuous motion, no matter how varied they are. 3D perception, using infrared and sensor fusion, is a key technology to enable high-mix manufacturers to automate their most laborious and difficult spray processes in a high-quality, cost-effective way.